What's up guys, so welcome to another data structure tutorial, and this tutorial is about linked list. Now first of all, what is a list? Now a list is a collection of similar type of elements. Now there are two ways of maintaining a list in memory. The first way is by storing elements of the list in an array, and the second way of maintaining a list in memory is by using a linked list. Now in my previous few videos I explained you how to implement abstract data types such as stacks and queues using an array. But you can also implement these abstract data types such as stacks and queues using a linked list if you want to overcome certain restrictions and disadvantages that are associated with an array. And there are many other uses of a linked list, and implementing stacks and queues is just one example. Now before writing a program on linked list, you need to understand certain basic concepts of linked list, which I am going to tell you, and after understanding those concepts, it will be easier for you to understand and write a program on linked list in C, C++, or other programming languages of your choice. Now firstly, a linked list is made up of nodes. This whole thing you are seeing on your screen is a node. Now a linked list can be made up of one node, two nodes, three nodes, or any number of nodes. Now this is an example of a linked list which is made up of three nodes, 1, 2, and 3. Now each node in a linked list is divided into two parts, the info part and the link part. The info part of the node contains the actual information, and the information can be in form of an integer value, float, char, etc. And the link part of the linked list contains or stores the address of the next node. And as you know, that pointers are used to store address. So basically this link is a pointer that stores the address of the next node. Now suppose there is a node in the list and the info part of this node contains some integer value, let's say 25. Now there's another node and the info part of this node contains some integer value, let's say 15. Now each node will have an address because each node is storing something. Each node is occupying some space in memory, and anything that occupies some space in memory has to have an address. So let's say the address of this node is 1002 and the address of this node is 1006. Now as I said, the link part of each node stores the address of the next node. Now the next node with respect to this node is this one, and the address of this node is 1006. So the link part of this node will store the address of its next node, which is this. So both these nodes will be linked. Now let's say there is another node in the list and the info part of this node again contains some integer value, let's say 10. The address of this node is 1009. Now the link part of this node will store the address of its next node, which is this. So each node in the list is linked to its next node. Now if this is a linked list made up of three nodes, then this will definitely be the last node. Now the question is that what will the link part of this node store? Because the link part of each node stores the address of the next node, but this is the last node. So this node has no next node. So in this case, the link part of the last node will contain null. Null means nothing. So always remember that the link part of the last node contains null because it doesn't have any next node. Now here's one important thing that I'm going to tell you about linked list. Now this node is storing the address of this node, and this node is storing the address of this node. But who is storing the address of this node? No one. And there has to be someone to store the address of this node also. So for this, we have a pointer named start, and this pointer stores the address of the first node of the list, and the first node of the list is this, and its address is 1002. So always remember that the address of the first node of the list is stored by a pointer named start. Now this start is a pointer, and pointer, as you know, stores an address. And using this start pointer we access the linked list. Now some of you might have a question in your mind that why do I need this start pointer? I can access each node of the linked list directly, like I can access this node of the linked list, or this node of the linked list, or this node of the linked list directly. So why do I need this start pointer? Now you have to understand that a linked list doesn't allow random access, it allows sequential access. Now if this was an array containing three values 25, 15 and 10, then I could have accessed any element randomly because an array allows random access. I could have accessed this element directly using its index number 2, or I could have accessed this element using its index number 1. Now the linked list doesn't allow this, it doesn't allow random access, it allows sequential access, which means that if I want to access this node in the linked list, then first I have to visit the first node, then the second node, and then I'll reach this third node. If there was another node in this list, which is the fourth node, and I want to access the fourth node in this list, then first I will have to visit the first node, then the second node, then the third node, and then I will reach the fourth node. In the same way, if I want to access the second node of this list, then first I will have to visit the first node and then reach the second node. So this is what sequential access is, and we can only access the linked list from the beginning, which means from the first node. This is the reason why we have this start pointer, because we need someone to store the address of the first node, because if we don't have the address of the first node, then we cannot access the linked list, because this first node is the entry point into the linked list. And the address of the first node is stored by start pointer, and using this start pointer we can easily reach the first node or access the first node, and from the first node we can go to the second node because this first node has the address of the second node, and from the second node we can go to the third node because the link part of the second node has the address of the third node. Now this start does not have any predefined meaning. The start is just a pointer variable and you can name it anything you want in your program, but start seems to be a more appropriate name. But this null has a predefined meaning. The meaning of this null is nothing or empty, and with the help of this null we can check if the linked list is empty, because if the linked list will be empty then the value of start will be equal to null, because even if there is one node in the linked list then the value of that node or the address of that node will be stored by pointer start, and if there is no node in the linked list then start will have no address to store. In that case, the value of start will be equal to null, and if start equals to null, then it means list is empty. Now there are various operations that are associated with a linked list, and the first operation is traversal. Now traversal means visiting nodes of a linked list starting from the first node, one after the other in sequence, until we reach the desired node or until the end of the list. And we start from the first node because we can only access the linked list from the first node. Now display means printing information from the info part of a node. So if I use display function on this linked list, then 10, 15, 55, 75 should be printed. And traversal is used in the display function because we have to move from one node to the next. Like first print the information of this node, then move to the next node, and then print the information of this node, then move to the next node, print the information of this node, then move to the next node, and so on. Now searching means to search for a particular information in the linked list, and information is present in the info part of the node. So suppose I want to search, is there a number 55 in this linked list? Then I'll use search function. Now insertion simply means adding or inserting nodes into the linked list, and nodes can be inserted at the beginning of the linked list, at the end of the linked list, or between nodes. And separate user-defined functions are used for each one of these. A separate function is used to add a node at the beginning of the linked list. A separate function is used to add a node at the end of the linked list, and a separate function is used to add a node between two nodes. Now first I'll talk about insertion at the beginning. Now initially our linked list will be empty. The value of start will be equal to null. Initially, linked list will always be empty. And if I add a node into an empty linked list, then it will look like this. And suppose the address of this node is 1002. So start will store the address of the first node. Now this is the only node in this list. So this is the first node in this list and also the last node in this list. Now if I add a node at the beginning of this list, then the new node will be added at the beginning. So this is how the linked list will look after adding a node at the beginning. And suppose the address of the new node which I just inserted is 1006. So the value of start will also change, because start always stores the address of the first node, and in case of add at beginning, the new node which is inserted at the beginning becomes the first node in the list. So if I add another node at the beginning in this list, then the new node will be inserted here at the beginning, and that node will again become the first node in the list. Now insertion at the end simply means adding a new node at the end of the list. Now suppose I insert a new node and the address of that node is 1009. Now the link part of this node was previously null. So now the link part of this node should change, because the link part of this node should now store the address of its next node, which is this. So both these nodes will be linked, and the new node which is added at the end becomes the last node in the list, and the link part of the last node is always null. Now insertion between nodes are of two types: insertion after a given node and insertion before a given node. Now let's say there are three nodes and I have named them node A, node B and node C. Now let's say I want to add a node after node B. So a new node will be added here between node B and node C. So let's say a new node is created and its address is 1009. Now the link part of the new node should store the address of its next node, which is this. So 1012, and both these nodes will be linked. Now the link part of node B should store the address of its next node, which is the new node which is just been added, and its address is 1009, and both these nodes will be linked. Now let's say I want to add a new node before node B. So a new node will be inserted here between node A and node B. So let's say a new node is created and its address is 1015. Now the link part of the new node will now store the address of its next node, which is this. So both these nodes will be linked, and the link part of node A should now store the address of its next node, which is the new node we just created, and its address is 1015. So both these nodes will be linked. So this is how insertion before a given node and insertion after a given node works, and this is called insertion between nodes, because a node is always added between two nodes. Now deletion means to delete any node from a linked list, and a node can be deleted from the beginning of the list, from the end of the list, and from anywhere in between a linked list. Now let's say I delete a node from the beginning of the list. I delete this first node. Now if I delete the first node, then the second node will become the first node in the list. So this node will become the first node, and the address of this node should be assigned to start pointer, because start should always store the address of the first node. And since this node has been deleted, this node becomes the first node. Now if I delete the last node from this list, then this node becomes the last node, and the link part of this node should be null, because the link part of the last node should always be equal to null. Now if I delete a node from anywhere in between this list, so let's say I delete this node. Now this node is storing the address of this node, but this node has been deleted. So this node should, so the link part of this node should now store the address of its next node, which is this, and its address is 1015. So both these nodes will be linked. So this is how deletion works. So this was the basic concept of a linked list, and one last thing I would like to tell you is that the nodes of a linked list may not necessarily be located at contiguous or adjacent memory locations. The nodes of a linked list can be scattered around different parts of memory, and it doesn't matter in case of a linked list as long as the link part of each node has the address of its next node. The order of the linked list will be maintained, so there is no real need for nodes to be stored in contiguous memory locations. Now from the next video, I will start explaining you how to write a program on linked list, and my first video will be on starting the program and how to write the main function. The second video will be on display function. The third video will be on how to add nodes at the beginning of the list, and so on. Now in this series, if you are a beginner, then the first, second, third, fourth and fifth videos are important, and rest you can pick and choose. So that's all for now, and thanks for watching.